right. So we have Mohammed with us.
Yeah.
Uh, so, uh, hi, Mohammed. How are you? Can you hear us? I guess the speaker. Just check your mic.
Hello.
Yeah, we can hear you now.
Yeah,
Yeah.
hi. Thanks a lot, guys, for inviting me for this talk. I was looking forward to it, and
Mhm.
it's awesome. Before you get started, I just want to do some housekeeping. So, is my sound fine?
Yeah.
Yes, it's perfectly fine.
Because I was my camera is not functional, so you will see I won't
Mhm.
be putting using that.
Mhm.
Also, in the settings, I was looking at I put the high resolution audio also
Mhm.
on. So I was wondering if it's not like jerking or stuttering or anything like that, right?
No, it's completely fine. Like crystal clear.
Okay,
Right, better than
fantastic.
my voice actually.
I'm just I'm just using a high gain condenser mic, so you might hear
Yeah.
some sound in the
Mhm.
background. Okay, I'm going to share my screen with
Yeah.
the press. So I'm just doing that now, and let me know when you can see it. I know there's some issue with the okay, where is it? Moment. Okay, so I click on the share button, window here, share. So first, tell me if you can see the screen.
Yes. Now we can see it.
Okay, so great. So you're the maestro here, so let me know when I can get started.
Yeah, perfect. So, Arnim, I guess we can just keep ourselves backstage and let the stage for Muhammad. So, over to you and keep rocking.
All right, thanks a lot. Also, so I want to start by saying thanks to your team for giving me the opportunity to speak, and to the viewers who are here, to the listeners, on this Saturday, which is a day for the loved ones. So I thank you for sitting for this talk. So I'm basically going to be talking about setting up a smart contract testing environment in the cloud, and I'll focus on one particular tool. So you might be thinking in your mind, okay, why am I doing it this way? Why don't I just talk about Slither? So the way I approach this is the problems which I faced, right? So my system is an old i5 HP running on 8 gigabytes of RAM and has an NVIDIA which is like one gigabyte, right? And I use it for my own development stuff and this and that, and it's problematic. So I was always on the lookout for a some sort of a cloud kind of a development environment. And in my study and research of it, I came across Gitpod, which I'll be talking about. Okay, so let me just take a step back. So a quick first of all, this is what we're going to be going over. As you can see, there's a lot of stuff. It just looks like a lot because this collateral will be shared. So I wanted to like pack it with information. Basically, in a nutshell, we'll talk about Slither in general. Just one moment, my mic is sort of not. Right. Okay. So we'll talk specifically about Gitpod pros and cons, and then we'll talk about Slither. Okay, so moving forward, so just a quick brief overview about myself. So my name is Mohamed X, or call me Mohammed. My background is basically I'm an R&D guy. I used to work for the American government once upon a time pre-pandemic. Post that, some things changed, as the pandemic was a life-altering event for everybody, and I sort of got into the Web3 area. So while exploring the Web3 area, I got interested in it, and then I hopefully wanted to do some, make my own thing. So you see, this is why I put myself down as the founder of the startup. I have two startups which I'm sort of trying to look at. One is called BlokFiny, other one's called Games. I'm also a gamer, Call of Duty and Valorant and more Mortal Kombat. I'm from that background, so I wanted to do something in that area. Also, information security in general is like I won't say passion. I just view the whole thing as a game. It's something I used to do. I used to do some web to bug hunting, specifically in the famous bug bounty hunting platforms such as Hack the Box, sorry, not Hack the Box, like HackerOne and Bug Crowd. Of course, I've not got any P5s yet. I got some P1s and P2s. Yay. And so taking that momentum of my interest in security from the web 2 side, I got interested in web 3. And then I slowly started investigating the web 3 security aspect. When you read about these hacks, it's really jaw dropping, right? I mean, if it was me losing that kind of money, I would be financially ruined. So basically, those were sort of the motivators for me to sort of get into this area. And I sort of stumbled upon this community called Immunify, and these guys are really great. I mean, there's some good people there. Adrian Hetman was here, and there's a bunch of others also. And I met Not Hacktivist, and then who introduced me to RazorSec. So I mean, it's a quite a vibrant community with people who want to really help each other. Also, to the moderator, if I'm speaking too fast, just say, "Yo, man, just slow down." All right. Uh, Okay, moving forward. So, the way I've designed this is that there's going to be just a quick bunch of slides, and then I also have a workbook. Okay, I just changed my screen. Can you see the screen change? Hello.
Oh, yeah, your screen is clearly visible.
Okay, so the screen has changed, right, to this Unchained thing, which is there on which is this Hack MD workbook, right?
Right.
Yes, yes, we can see it.
Okay, so I'll be shifting back and forth. So I've come back. So okay, so let's dive right into it. So we'll be talking about Gitpod. Gitpod is basically a cloud development environment, and then we're going to talk about Slither, which is a Solidity static analyzer. So static analyzer meaning that it analyzes code which is already deployed or sitting on your machine, and it's not changing. It's not dynamic in nature. This is why it's called a static analyzer, right? So let's now talk about why would somebody want to even bother with a cloud development environment. So as I pointed out in the beginning, was that if people might have certain constraints, with their computing process and the CPU power constraints, then you'll always keep complaining, and the cloud development environment always it seems like a better option. Now in the cloud development environment space, you have famous ones, which is AWS Cloud 9. But as you know, AWS tends to become a little bit pricey, so I've used it for doing some amount of development work. I'm not a coder as a background. I'm more of an experimenter. I like to experiment with stuff, look at code and see how it functions and see how I can find a weakness in it. And then you also have REPL.IT. REPL.IT, as you know, is another famous cloud development environment, but that's not used so much in production, and it's mostly for testing. So in my search, I came across Gitpod. So Gitpod, as you can see, it has a free tier which is really good, and I'll be showing an actual demo of all of this stuff, so you guys can hang on. So the most important reason why would anybody want to use is this particular reason. Now if you're a Python developer, for example, you have to keep setting up a Python virtual environment. You might forget, you might not forget. Every package is different, and you have to keep doing this for every new project you work on. Then you have the npm also, it tends to have conflict errors, right? You have to keep changing them. So I mean, having a cloud environment fixes all of this. Of course there's a security component to this also. So far Gitpod has not have had any major data leaks of especially their authorization tokens, because the way it works is that it's sort of you open your Gitpod repository or a GitLab repository in it, and the way it functions is that it does its authentication by the GitHub auth token function. So far nothing has been wrong with it, and it's actually being used in production. So I will show that. The other important thing is that these are some cons. Of course, there's no solution which is perfect. You can see you can't install some stuff, and there's an idle timeout, especially if you're on the free tier. You have to restart whenever you restart the instance. You have to keep installing the packages, but that is also fixed by this thing called pre-builds, which I will get into it a little bit later. If you have any questions, just put it into the chat, and I'll attend to them by the end of the talk. I'm timing myself, so I'll make sure I keep some time for that. Okay, so when you start installing Slither, Slither requires a bunch of dependencies. You can see over here. Let me just maximize this image a little bit. So these are the dependencies. Hopefully, you can see my screen with the image. So, you need the Solidity compiler, and then you need this old C selector. So the way how Slither works is that, when you do the analysis of your Solidity file, often they tend to have different versions, of the compiler, which is called the Pragma compiler declaration. So you use Sol-C to actually change between them. So you need Solidity, the Sol-C compiler. You need the Sol-C select. Of course, you need hard hat, because Slither works by using hard hat's libraries also. And hard hat is a Solidity development environment. What I also do is I also installed Truffle, because Truffle is also similar to Hard Hat. For some reason, when you have unexplained errors, instead of diving through going through all of the JavaScript configuration files, this often solves the problem. I know that sounds funny, but this is my experience. And then finally, you install Slither. Slither can be installed in one of two ways. You have the Docker image, which you can pull from their official repo source, but when you pull it down, the problem is that it's not the latest one, right? So then you will have to go through the trouble of manually, upgrading all of the packages within it. And then, if you want that state, you'll have to sort of recompose your own Docker file. So, but the benefit of that is you don't have to go through this whole installation. And this is the great thing about Docker files. Like, it's like a complete contained unit of everything you need. You just start it and plug and play, right? And then, of course, Slither is an official pip Python package. You use the pip3 command to actually run the install. So that's the workflow. And then, okay, so the YAML. What is this YAML thing? So as I mentioned, Gitpod, since it is a cloud development environment, the way it works is that you open up an instance. When you open up the instance, and then you start installing stuff in it, right? For example, if I want to run, just one moment. If you want to install Slither, you'll have to do all the things that I asked. But the benefit is that they have this thing called a pre-build and a startup sort of functionality via a YAML file. What that means is that you put all that stuff in it there, all the declarations. Every time you restart your instance, it gets downloaded and installed, and a whole bunch of tasks which you can automate to just get started right away. Okay, so then before we that, so now the whole purpose of this conversation about Gitpod and Slither, like why are we bothering with this stuff, right? Is because we want to use it for security. This is of course, prior to me, there have been some excellent talks regarding this topic, and post my talk also, there's going to be a lot of people talking about it. But this is just sort of a snapshot of the whole security threats, the security threats in the DeFi space, right? So this diagram is taken from a paper. Once you get my this particular deck, you will see at the end, I put all the references down, so you don't have to worry about that. So this is basically what the landscape looks like. So all blockchains have these components. You have the DeFi protocol, which can be attacked, the smart contracts, the EVM, and the internet. Now these can be interchanged for the chain which you're working for. So the threat stack is, these are the types of the attacks. You have protocol attacks, you have market attacks, and you can see a bunch of these things, right? And of course, then you have the attack techniques. We all know about the flash loan, which happens all the time. Signature exploit was, they could have been done some. I'm not sure. I've not read a lot of these postmortems. I'm sort of catching up. I'm sort of new in this area. And then of course you have these bunch of other integer overflow and underflow. Just recently there was one token which got exploited because of this particular exploit, right? And reentrancy, you must have heard about this so many times, right? Apparently it's a very common kind of a vulnerability. Even though it's talked about so much, it still exists. So then the question comes in your mind, okay, man, if everybody knows this stuff, why are why are similar hacks happening over and over again? Well, the answer is quite simple, because a vast majority of the projects are just forks of existing projects. So, Razorsec, for example, comes up with their Razor token. Most probably it'll be an ERC20 token, and they most probably could have forked it from somebody else, and as a base, of course, and then built on top of it. But what happens is a lot of these projects, and then somebody, a third party like myself, would then fork Razorsec's token and then try to build my own stuff on it. Now the problem is that in the pursuit of gaining finance, gaining funds, as you know, because the Web3 is a very hot space. And when you say Web3 to a or blockchain to any investor, he starts literally salivating, right? So they just want to grab it quickly, so they just fork these chains. They don't do any code auditing, because who wants to spend money on that? In the end, it's about just getting our token out, getting the TVL in, and then we'll figure all this stuff out, right? So that's just my opinion on that particular matter. Okay, and then this is just a quick, these are the top 10 attacks, taken from where, again, I've referenced. This is from Consensus. They have this good repository called Consensus, top 10 vulnerability attacks. The links are all there in my deck. And out of them, these are the most common ones. So you have the reentrancy. I put the three exclamation marks to indicate that this happens all the time. You can see it's because of an external contract takes over the control flow. You have front running, which is faster transactions by monitoring the mempool for profitable transactions. An interesting note about front running, which you must have heard, in the NFT space, front running is a big deal. So, and a lot of the, for example, whenever they have a new NFT drop, if you hear some guy suddenly has bought all of the NFTs, in a matter of seconds. How did this happen, right? They use these things called MEV bots, right? Flash bots, they're called. So these flash bots are these automated bots that actually run transactions. But how do they work? Like, how do they actually work? So in the Ethereum chain, very quickly, whenever a transaction is being done, the transaction waits in this area before it gets validated by a block. So that is called the mempool. Somebody is looking at the mempool and knows what transaction is going to go through it. So then they use a bot to actually intercept that, and then you see it's called front running because they intercept it, and their transaction gets validated quickly, because they will give a higher mining fee to the validator. So this falls under the area of MEV. I do recommend that you guys have a look at it to understand what that is. And then you have timestamp dependence, which is manipulation of the byte. This is what the miner will do. You have the integer overflow and underflow, which is risky of manipulator. You have DOS, denial of service attacks, which is also mentioned by in our previous talk. Denial of service attacks can happen on anything. It doesn't matter if it's the blockchain, if it's any system. Fundamentally, it's just overloading the server, overloading the RPCs with excessive amount of requests, blocking everybody else, right? So that's what fundamentally it is. And then there's insufficient gas griefing. I haven't come across any particular postmortem that actually references this. And forcibly sending eth2 contract, this does exist. I don't fully understand what that is, and I haven't read any, but these are also being included. These SWC thing which I've referenced here, this is the smart contract of weakness classification registry. Works a lot like the CVE. If you're from the web2 bug bounting space, where the common vulnerability database. So SWC is like that for the blockchains. The only caveat here is that SWC was maintained by Consensus, but that the team or whoever was sort of responsible for it has sort of left, and it's no longer being maintained. But that's something to look at. Then very quickly about smart contract hacking 101. I have taken this from this particular Twitter user, OBHED812, and this was also corroborated by a few other known auditors, that this is basically a framework. As you can see, you have the threat modeling part. You do a bunch of stuff, a lot of testing. And then there's the informational gathering, which is the reconnaissance part. In the whole steps of the traditional penetration testing, the traditional bug hunting methodology. This is just following that. It's just filling it up with Web3 stuff. So you have the information gathering, find out about what it is, and read the papers and the blogs. You do some threat modeling, which in plain English means that you look at the code and then you test for it. How do you test it? You test it via a hard hat a test. You write the test, or you use another project called Foundry, for example, to write the test. So that's the threat modeling. Then you do the vulnerability identification. After you've done the threat modeling, you look at the code, you see the right calls which can be attacked. Then you actually run the exploitation, and then there's the post exploitation review. Now, another fundamental difference between Web 2 and Web 3 hacking, and the reason why, for example, the question is, excuse me, and the question is, like, the number of people in the Web3 hacking space, or penetration, I don't like this word hacking, by the way, penetration testing space, is a lot less than Web2. Is that most of the bug hunters in the Web2 space are highly tool dependent, right? You use Burp Suite, you use Acid Node, you use all of these other well-known tools that automates the whole process, and it tells you exactly what to do, and then you just sort of exploit it. But why Web3 is fundamentally different is, speaking from a Web2 perspective, Web3 hacking is technically exploit development, or malware development. Because in the Web3 space, you look at a vulnerable contract, you see those functions which are exploitable, but in order for you to exploit it, using a tool will not help. You will have to write the logic, you will have to write an exploit contract to take advantage of it, right? So that's an interesting point to just keep in mind, right? So what is Slither? Slither basically, as I say, is a static code analyzer. It's written completely in Python, which is quite amazing, and built over time. It's a highly complex package that uses a bunch of libraries. So it does automated vulnerability detection, and it gives you a whole lot of optimization, notifications. It helps you understand the code. I primarily use it for understanding, like I said, because I'm not an expert in Solidity yet. I use this tool quite often to understand all the function calls. It gives me a good summary of what's going on, and stuff like that. Anyway, I will make a demonstration of all that stuff. Now, there are certain pros and cons, right? So the major pro is that it gives you a granular analysis of any kind of contract. There are like a whole bunch of these things called detectors. Detectors are these Python scripts which has been written by the people who made it. I forgot to mention that Slither was made by Trail of Bits. Trail of Bits are leaders in the security space, right? So these guys have a lot of experience in auditing all kinds of code. They've used all that knowledge and automated it, and they have made Slither, right? This is also another organization called Crytek. There's some relationship between Trail of Bits and Crytek. I'm not fully sure, so I'm not going to comment on it. So these guys have written these detectors. The detector is what detects all the faults in the actual code. Now, what are the cons? The major con is that this tool is definitely not for noobs, because for the first time when you see its output, you'll be like, oh my god, what is all this stuff, right? This is for either intermediate or advanced level people who understand Solidity code and how the EVM, or the Ethereum virtual machine, works. The other thing noted by prominent auditors is that it tends to be very noisy and tends to give lots of false positives, right? So that's some of the cons to keep in mind, right? Okay, and then so this is the thing which I had mentioned earlier. So what is the general advice about using tools in general? Now, if you're coming from the Web 2 space, then you have this heavy reliance on all of these tools. And so the one of the a lot of the advice which I've like read in multiple blogs is that, so a lot of the advice which I've read in the various blogs and through hanging out in discords is that these tools, in addition to giving you false positives or leading you down the wrong path, is that the actual bugs, the high value bugs, are not found with tools. Okay, it's found by manually auditing the contract. Manual auditing means like going line by line and then understanding what each function does, and understands in the contract how the values are changing, right? So that's an important point to remember. Okay, what are the targets? So we'll be looking at two targets uh, for using this tool. The one is called the Spork DAO token. You can see on the screen. One thing to note is that the way how Slither works is it does not interact with the chain or the contract in any way. The way it works is it fetches the contract and it compiles it locally. This is why you need a hard hat, right, or truffle. So it'll compile the contract locally and run the analyzers. So this particular target, the Spark token, as you know, ETH Denver recently happened, and in ETH Denver they had this Spark DAO. I don't know what that is really, but all I know is that I received in one of my wallets Spark tokens. I have never been to ETH Denver. I don't fully know what that is. I didn't register for it, so this is definitely a scam. It is an airdrop scam, in my opinion, right? So we'll be having a look at Spark DAO, which is, it's actually deployed, and we'll have a look at this other stuff, which I put it all here. And the other one which we'll be looking at is, Immunify, which is the bug bounty platform, and Razer Sec has some association with them. They put out community challenges, which is like, every fortnight, something like that. They put out a challenge. They give a bunch of wonderful contracts. They tell people to have at it, to improve yourself, right? So I'll be looking at one of their contracts also, albeit I have actually flattened the contract so I can use it. Okay, and then, okay, so that's enough talk about me. So let's get into it, right? So I'm going to change my screen. Okay, did you see my screen change? Hello?
Yeah, your screen is visible.
Somebody. Okay, great. So
Yeah,
what is this? So now what are we going to do? Yeah, sorry, somebody say something?
yeah, I'm saying your screen is visible. Like GitHub page is clearly visible.
Lovely.
All good, all good.
So
We are good to go.
okay, so what am I doing? So this is, a test repository. I've made this, and I'm going to demonstrate how to use Gitpod, right? So before I do that, to give you a quick overview. So Gitpod, right? So this is Gitpod. This is the actual cloud development environment. It's pretty good, as I mentioned earlier. If you look at their plans and pricing, their free tier is quite good. You get 50 hours per month. The way how Gitpod works is that it's working on Google Cloud's infrastructure. Every time you start an instance, it'll pull a Docker image. It's going to pull the Docker image, and then it's going to sort of instantiate it, and you're going to be able to use it. This particular Docker image has a bunch of packages within it. So I'm just going to bring that up. Self-hosting. This is the pre-builds. Okay, so and where did I put it? Here it is. So when you start up GitHub, what it does that it's pulling a Docker image. So it's pulling Docker image from here. So the Docker image is a pre-built image that which by default starts up, and it has all of this stuff. Actually, all of these packages are installed in it by default. You see, so you can do C, Clojure, Go, Java, and all of these things. In fact, it's quite versatile, and it has a bunch of templates. All you have to do is just run it, and you can just start writing the code. If you want to build a React application, a Python application, something in Node or JavaScript, it just runs right away, right? So the other thing I wanted to speak about are pre-builds. What are pre-builds, right? Pre-builds is as I mentioned, is when you open up a project and you sort of run the workspace from it. Now when you have your own instance and you keep installing, as you're working and writing the code, you keep installing a lot of these various packages and tools and blah blah blah, this and that, right? Now if you want to open a new instance up, you'll have to redo it, but you don't have to redo it, because you can actually automate it by using the YAML file. As I mentioned, you can see the command structure. You'll have a look at an actual one, and it'll reinstall it every time you actually started, right? So that's the other important aspect. Okay, yeah, it's also built for collaboration. Collaboration is like the at the heart of Gitpod. So what that means is, if you have a team of three people, Razor X two guys, they want to build out a DeFi game, for example. So both of them can be on Gitpod, and they can both be working on their own separate branches. I mean, the entire workflow which you on your machine, you can do it on the cloud. That's what I'm getting at, right? That's what I'm actually getting at. Then other, okay, pre-builds. Okay, startup tasks. So this is just the other thing, is as I said, you have the YAML, and there's a bunch of things you can do. Let's look at an actual file. Yeah, okay, so here's an actual file. So what's happening over here, right? So we declare this file right at the start. I'll show all that stuff. And then what it'll do, that every time you start the instance, also called a snapshot, it will run the Python http server, and it'll open up that portal, be running ready to go. And you can put in your own custom shell scripts if you need to, right? And they have these are open mode. These are like various terminals also it can open. Anyway, let me get to it. So I have, here's my repository. I've already logged into my Gitpod. Now this is what it actually looks like. So you have workspaces, you have projects, and you have settings. So projects, so the project is where the pre-building is occurring. You click on the new project, and then you choose your stuff. And what happens is that once you do it in this way, this project gets created. And every time you push code to your repository, the pre-build will build it automatically in the background. It'll keep rebuilding it in the background so that we can open a new workspace, right? So I'll get to that. So how do we start off? So right from the beginning, you've signed up with Gitpod, and you want to take it for a drive. What do you do? So you have your test repository, and the way you actually start using it is, there are two ways. One way is that you come to the beginning of the address bar, right before the https, and you type gitpod.io slash and the hash, and you press enter. Now what's that going to do is that now Gitpod has been activated, because it's linked to your Gitpod repository. And you can see, so what it has done right away is that it has pulled a Docker file with all of the packages that I mentioned. And as you can see, you're ready to go. So here we have it's familiar. It's exactly like VS Code. It's got a great terminal. You understand. Just so Right, so you can see this is at the moment running on a server somewhere. Okay, so it's in the United States, right? So anyway, so this is running on the Google Cloud infrastructure. I'll demonstrate that a little bit later. So we see over here, here we have opened up our instance. This is the actual the repository. Well, where's one moment? Let me just reopen that. Right. So we have the repository. Now this particular VS Code instance of within GitHub is now linked to this. So we can just quickly set something. I just want to show how it works. So readme .md, and we're just going to write something, repo test, and I'm just going to commit it and push it to the repository test. First time we just need to push the code. Okay, so it's pushed. Now when you come back, you can see over here, it's completely functional. There it is. I have pushed it directly from here. You can see it's quite fast. Nothing is happening locally. That's one benefit. So if you had like hundreds of megabytes of files which are going, you can see the commit over here. There it is. And here's a test repository, right? So and coming back over here, as I said, it's quite familiar. It's exactly like VS Code. You have the entire gamut of the uh, marketplace extensions. You can install some of them already installed. You can search for your own. You can quickly just, so the Solidity VS Code extension, is often recommended if you want to. This is also installed by default. So you see, it's running completely like that, right? So now, when I did the procedure to start up this instance, if you look at your Gitpod now, in the workspaces here, it's running. This thing over here, the first line here, this is your actual workspace. Now what happens is, for example, whenever I push something to my GitHub repository, it sort of keeps track of that via the commits. And for example, I'm running this and I lose it, so I just closed it. I closed it right now. But so if I want to return back to what I'm doing, it's right over here. I just right click on this, I click on open, and it's going to just pull the, it's quite fast, as you can see, because I've not installed anything over here. And it just pulled that Docker repository, and we are back to where we are at, and we can continue our work. Now the other thing is that its benefit is that you can open multiple instances. If you can see, now if you say what's the big deal, is then you can work on 2 or 3 branches at the same time. Of course, that's not a recommended way of doing, but for example, if you're debugging some code, something that's already deployed, you can use this in production. You can open up multiple branches, you understand, you can push all of the code to it, and of course, you will do a PR request. You will go through the PR, you will go through all of your PR requests and merge it as you want. All right, so now I'm technically on not on the free tier, but the free tier can let you do 4 of these all at the same time, right? 4 of these workspace instances, all of it at the same time, right? So you can see I have 2 of them running at the moment, right? So this is basically Gitpod in a nutshell, the actual part of interest to you. As I said, this is the, once I make the, when I click on the new project, I set up a new project. You can see why this exists is because now when I start to actually demonstrate Slither requires me to install a lot of stuff in the background, as I mentioned earlier. And so I don't have to keep doing that again and again. I'll just right click here, click on a new workspace, and you'll see it will actually work. Let me get back to my workbook to keep a track of what right. So you can see over here that the way you start it up is like this. There is a bunch of awesome tutorials on the official Gitpod YouTube. I highly recommend that you check it out. So we went through all of this, so we'll get to the actual Slither part. I'm going to close this instance. I'm going to close this instance. Okay, here we have it running. So all I did was, in my workspace, I have it prepared. You can see here, Unchained 2022. I've prepared this for this particular conference talk. And I just right click on it, and right click on this and click on open. And then it's right over here, ready for me to use. So here we have the actual, now it's installed. I have Slither running over here. So let's dive right into it about Slither in general and its quick functionality. So first let's see about all the stuff that Slither can do. So of course, we can have a look at the repo, but this is more hands-on, so you get to see what's happening. You can see it can do a lot of things over here. Its syntax is very simple. All you have to do is you write the command, you write the target, and you put the flags. The target can be as a local soul file, which I'll show you in a moment. It can be an entire directory, that is your npx hard hat project which you're working on multiple contracts. You just run Slither, you give the project the directory, and it'll work. Another good thing is that it fetches contracts directly from the from the network it is deployed to, right? It works with a bunch of networks. You can see the mainnet, Robson, Cohen, Ringb, all of them, majority, even BSC, it works. And also on the L2 solutions are RB, and I think there's Optimism is there. No, Optimism is not there. So it works with RB. RB is Arbitrum, which is the Ethereum L2 scaling solution, right? And then there's a bunch of interesting flags. What is of interest is you can suppress the compilation via truffle. You understand, as I said, you can the way it functions, that it fetches the contract, it compiles it locally, and then runs the analysis, right? You can suppress that. You can do a bunch of stuff over here. There's some ether scan options. If you only want to look at the source code, if you only want to look at the bytecode, the bytecode is when you have a Solidity file, it goes to the compiler, it gets into bytecode, and then it gets deployed onto the chain, right? So, and here the if you have a key for the specific network, you can use that and call it. And okay, so the detectors is what is of interest. It lets you sort of you can choose what you want to actually find in your code. So I'm going to run the default that does all of this. You can see it looks for delegate calls. You can look only for the compiler issues, if there's any functional problems, if there are delegate call loops, a bunch of other stuff like reentrancy stuff. So you can see all of this can be done. And we can also list it. I will also run that and show you. And what others? Printers. So the printers are an important aspect for using this particular tool. So what are the printers? The printers puts up the analysis in such a way that it will be digestible to you, right? Instead of just lines and lines of complicated stuff, which I'm going to show you, it actually will do that. And it also has this another interesting thing called the triage mode. I haven't worked with what this is, but it spits out a JSON file with all of its I imagine it somehow works. It sort of works into the triaging pipeline, right? Adrian Hedman would know more about this than me. Okay, so let's get into it. So first, I am going to let's go to my presentation. What I'm doing is I'm looking for the our target. So let me look at the where is it? Dependencies. Targets, right? Okay, so the spark token. So what we're going to do is we're going to first have a look at what it looks like deployed on the Polygon chain. So here we have the spark token. This is the spark token. This is Polygon scan, and you can see the bunch of transactions which are happening, all zero transactions. These might be automated, I don't know. You can see that it's not very popular at the moment. As I said, this is very peculiar. It just sort of showed up in people's wallets all of a sudden, right? So and then, like I said, it sort of raises my eyebrow. So okay, so here we have the actual contract. So let's copy the contract. We'll get back to here. If everything is properly installed, we will run the analysis. Oh, sorry, one moment. That one is not the actual tokens. Contract. Okay, so the main contract is actually on the Ethereum chain, right? So the main contract is on the Ethereum chain. Oh, this is my mistake. It's also on the Polygon chain, but the main contract is on the Ethereum chain. So in the Ethereum chain, you can see that this tick mark means that it's a valid contract, right? And if you have a quick look, you can see the contract source. It's running on 0.8.0. There's nothing out of the ordinary over there. So we are going to run the analysis. So I just ran the analysis over here. As you can see now, it has spit out a bunch of stuff. Right? I'll run that again one more time just for brevity. Okay, so now this is the output of Slither. Slither tells you a bunch of stuff. Like it's quite detailed. It gives you color coded information. It gives you color coded information about its findings. So as you can see now, the yellow part of it is these are areas which you have to sort of pay attention to. I don't fully understand each one of these lines, but what I do understand is that it tells you there's an access control issue over here, and it gives you the actual line numbers of where the problem is. There's a access control, another issue with revoke role over here. There's another one over here called the setup role. So it's something related to access, or the access control is an issue. Again, don't forget that this can be noisy. Like the advice which I have got is, once we actually have this particular tool and we get this output, we have to actually go through them line by line and try to understand whether it's of interest or not. And the stuff in green is informational. Okay, it's telling you that there's this bunch of things. It's they saying that this particular thing has never been issued, never been used. Like why put functions or code which is never being used? So that's interesting thing over there. It tells you about the type of compilers which this thing is working with. That is of interest. Then it also gives you some advice that the this particular symbol should not be used, in this particular instance, which is in this particular line 192 to 194. So it gives you, so now this information seems a little bit garbled, right? So let's look at the printers. The printers, look at one of the printers, look at the syntax for the list printers. So we're going to see the printers. The printers are the stuff which is humanly readable. So let's look at the printers which exists. Sorry, syntax error. List and printer. Right, so these are all of the stuff which is humanly readable. Of interest to us is, let's look at the contract summary. So I slither, and the syntax is hyphen hyphen print, and we type it. So it's hyphen hyphen print, and we're going to do the human summary of the code. So now it's going to fetch it. What happens is it has fetched the contract, and it has compiled it locally because hard hat is there, and it's telling you some interesting facts here. There's some optimization issues. That's not a big deal. Anything in green and yellow is for interest. Nothing which is high, you can see. So it tells us there's a bunch of enumerable strings, enumerable set. You have like a bunch of functions. What are the ERCs which it's calling? The ERC20 info. The Git talks about a race condition. Is it a complex code or not? So let's look at some more printers of interest. Okay, we'll look at the function summary. This is also, I will just press up. So we'll look at the function summary. So the function summary, it will take any sort of a contract, and then it'll give you a summary of all the functions that have been called or used in that particular contract. Function summary. So yeah, so it's quite detailed. It's quite detailed. I have to make your life simpler. I have done this in advance and put it in a text file which can be more easily readable. So in the function summary, just so this is what the function summary will actually look like. So it tells you it is which is the contract which has been used, and then if there's these are JavaScript type of stuff, if there any inheritance involved, what are the contract variables. It tells you all of the major functions, what is the visibility, if there are any modifiers, as it was mentioned in our first talk, that how a lack of use of the modifiers makes it easy for anybody to call that function in an unintended way, right? So that's a very important. It gives you some more information, whether it's read or write, or whether it's an internal call, whether it's an external call. If there's some more stuff, it'll come up over here, which are the modifiers, which is visible or not. These are like summaries, and then these are, again, it does multiple how should I say, cycles of analysis, and then gives you similar kinds of information. What are the function, visibility, stuff like that. Okay, so this is another, some more detailed. You can see it's quite detailed. It's a lot to digest, to understand, but the good thing is it gives you a good overview of, from an auditing perspective, what to look at. If there are functions of particular interest, right? So I'm just going through it. So that is the function summary. Now what else can we look at is of interest? I know there are 15 minutes left for my talk, so let's look at some more, anything, one more of this, and then we'll look at the community challenge, so I can show you that it does indeed detect stuff. Right, okay, so function summary, we looked at the human summary. Let's look at the function ID. So Okay, so this is a little bit more condensed way. This will tell you that particular token or that particular contract, what are all the functions which are being called, right? And it assigns an ID to it. So when you have all of these functions, then you can quickly reference it and see which one is of interest to you, or are aware that that particular function is often prone to vulnerabilities, and it's often overlooked from an auditing perspective, right? So that's for the contract which has been already deployed. So let's look at the Immunify community challenge which was there. So here's the challenge. Now the actual code looks like this, which was Immunified challenge. So okay, so this is the actual vulnerable code, which was written by one of the members for the analysis. It's a staking contract. I know that because of this particular declaration here. So it's a staking contract, and you can see there. Here's the address staker. So this is a staking, and this is a vulnerable piece of contract, and our exercise was to solve it. I did not solve it yet, right? I'm still looking into it. Now, what is of interest, what I'm trying to get at is that when you download the contract via wget function or whatever function and try to run Slither on it locally, Slither is going to give you a bunch of errors because of it'll keep saying this is not found, that is not found, especially these open Zeppelin contracts, right? So in order for it to, there's a process called flattening. So when you download a contract for any particular analysis, you have to flatten the contract. So what that means, that it will sort of uh, add all of these external contracts, what is the code which it actually uses, is going to put it into the main contract. So a flattened contract, so you just have a look at the difference over here from this particular lines 1 to 7. When we flatten the contract, you can see now it becomes a lot bigger. And what's going on is that from each one of the open Zeppelin calls, it is calling the actual function within them, right? So now it is all locally within this contract. So it has also increased in the total number of lines. And now when it is in this flattened state, we can run Slither on it. So Slither, and I had named it challenge flat, and here's the output, and you can see that it indeed found now an error here. So here is, it says in red, is that there is a re-entrancy problem with this particular contract. Now I don't know if that is true or false, but this is what it's saying there. And like I said, the advice I was given was that once you get this output, we have to take a look at it closely. So it's saying that there's a re-entrancy problem in these particular 683 to 689. It's telling us it's over there. Here's the call, which is the source of the problem: the token safe transfer message sender. Now like I said, this is the part which I have to do my own understanding and auditing on, whether if this really isn't the case. So my point is that it does work. Now in reference to this, Slither actually has been able to find you know valid bugs. So I'm now what I've done is I have gone into the critic Slither's original repository, and within them it is showing you all of the trophies means that things it has worked. So Slither was able to correctly show that there was this problem with this particular contract. More recently, so there was this thing called hold my beer on the token. There was definitely a reentrancy there. You can see it's detected here again, lack of value check again here and here. So you can see that it actually does work, right? But of course, once we get our complicated output, then we have to sort of run our own analysis, write some tests in hard hat to actually exploit it, right? Exploit this particular vulnerability. Okay, so let me get back to my this thing. Have I covered everything? Let's see. Yeah, so that's Slither's generally all of its functionality, which is of interest. Like I said, what is important to you is you can run it locally, right? And you can look at its printers. So its printers tells you a lot of interesting information. Now it also does, it shows you the CFG, which is the control flow a graph of each particular function. So the way does that, it's quite detailed, and once I'm not going to run this command right now. I've done it in the prior to, because it spits out a bunch of dot files, so let's have a look at the report. So these are the call graphs for one particular token. So this is in a dot format. So to see the dot format, is it's a diagram. So let me bring that up. Okay, so it's a dot diagram. We're going to use another online tool called plant text. Plant text is, if you guys know about plant uml is a uml diagramming software. So there's an online compiler also. So this particular code which it has given, which is, the it's a dot file code. It helps you see diagrammatically what are all the calls that are occurring in that particular function, right? So if I run this, I'm going to run it. Diagraph name. Okay, so here it is. So here's the a diagram. So this is the control flow graph of that particular contract, of its specific function. So it's telling you diagrammatically that you have an ERC20 call, and it is possible this is the function before token. It tells you in what way it's functioning. It's telling you how all the access control stuff is working, the set role, grant role. Now, it from a diagrammatic perspective, this looks like a lot of gibberish and spaghetti, but this is the thought process behind the actual writing of that particular contract, right? So this is what the CFG actually looks like, and it's quite detailed. It's very, it's quite detailed. You can have a look. And what I would use this for is when I'm learning about the particular contract. If I don't understand how two particular functions that are being called in two separate locations, what is their relationship and how are they actually functioning with each other, right? So instead of drawing it out with my hand or imagining it, I would definitely use a CFG, right? So that's the control flow diagram. What else of interest? See, I showed that. Okay, so those are the important things about Slither. So an important thing you guys have to keep in mind about Slither in general is that this piece of advice, that it is a high noise static analyzer, that its output needs to be critically analyzed. And then once you what in my opinion, the best approach is that to use this particular tool, which by the way there are like a whole sea of tools. Oh, and as a tangent to what I'm saying, if you can still see my screen, you can also have a look at this excellent website which I found. And what it is that it is a compilation, a curated repository of web3 stuff, right? It's got like a bunch of tools. You can search for it, and there's 101s and videos. The reason why I'm showing you this is it's related to what I'm talking, is that there are a bunch of tools that does the same thing. In terms of an analyzer, there's a bunch of tools that does this analysis, and Slither is not the only one, is one amongst many, right? So that is that. Okay, I think I've covered most of it. That's it. That's all. That's enough talking from me. And if you guys have any more, I still got 5 minutes left. If you have any questions, please feel free to talk to ask them, and I will definitely, answer them to the best of my technical ability. Thank you very much. I would like to hand over the mic back to the organizers. Hello.
Yeah, hello.
Yes.
Hey Mohammed, like it was a very nice section. I was actually looking forward to follow this because I also wanted to do the same to set up Slither so that it becomes handy for me, right? So yes, it's
Lovely.
very much needed. And yes, like I wanted to ask, according to the perspective of a user, or you can say a person just getting his head around the Slither, right? So,
Yeah.
what would be your suggestion to him or her, like kind of a approach that a person should follow while taking data from Slither, right? Starting with printers or making graphs and continuing with the issues and all, like how to approach the data from a Slither.
Sure. Okay. So I will give you a quick rundown from the top to
Mm-hmm.
bottom, right? So
Mm-hmm.
first of all, you need to, find a contract. You find a contract you want to actually look at, right? So what I recommend is going through Immunify. They're not paying me to say this, all right, guys? I'm just saying that. Go to their
Yeah.
Immunify bounty program. There's tons of money to be made if you can crack one of them. So you find the contract that you want. Secondly, you can do one of two things. You can either download the contract, locally, to your hard drive and flatten it, like I said, and then run the analysis, or you could use Slither to actually run it from the deployed chain itself. Now, once you get this information, as I said, an important point is that you need to have some understanding of Solidity, at least in general, right? Maybe not so deep, but in general, so that the output that you get are excellent pointers for you to actually investigate. For example, I would run Slither, I would run the printer, I'd look at the function ID. Function ID, it'll spit out like 100 functions. Then you have to go through the painful process. I know it sounds painful, but making all that money is not easy, right? And the people who build these contracts are highly paid people with huge teams who spend most of their life, most of their time every day building this. So you have to look at each one of those contracts, find out what they do, or an easier way is look at the postmortems which have been given by in the Immunify Medium blog. They have a bunch of them. You can go through them, see which function calls were the source of the problem, right? And then you can then see if those functions exist in the output, and then look at the code surrounding it and understand the logic. Right now, I don't understand. Like I said, I'm learning Slither myself, albeit at a little bit rapid space, because I want to also, find a bug here, eventually. So to understand the code logic that goes behind that particular function. And definitely, the other thing which I can recommend, I highly recommend, which I'm also going to do and am doing, is to actually attempt the CTFs. There's some excellent CTFs called Ethernaut, and like there's a bunch of them. You can see, you can just Google it and find like a bunch of them, or you can go to that website which I mentioned, web3sec.com, and you go to the CTFs. The CTFs tells you in what manner to look at the function, in what manner to see how it's particularly exploited. Now, as I said, once you get all of the output, you see a lot of red. Don't get too excited, because it's a high noise, it's a high noise output. And then you have to sort of reaffirm them, you have to sort of verify them using other tools, or if you are very good at reading the code and at building logic, to actually use that logic to find out the source of the problem. Hopefully I have answered the question.
Yes, yes, it does. And yes, a lot of information and a wonderful tutorial that has been covered by you. Really been great. Can you share that site link with us, the Web3 sec
Okay,
that you
sure. It
pointed out?
is W3BS3C. I am typing it out in the
Yes,
in
in the private chat, you can send it here and we can just forward it out.
okay, I'm gonna do that right now. It is web3sec.com.
Got it. Right. And yes, and to the viewers, the slides will be shared as well after the end of the event, and any of the resources that are linked to this tutorial or anything like that will be shared as well. I will just communicate with Mohammed, and We'll
Sure.
take down all the notes and we'll share it with you guys. And once again, just wanted to thank you for coming down to Unchained. It was great. And yes, hopefully, many of the guys who are actually looking forward to come into the Web3 security, it would have helped them because
I
they
I
would
I
be
I, I definitely hope so.
right. Yes. Because like yes, it keeps the task very handy for all the users to not having your own machine and just keep the things in the
Yeah.
cloud, keep your security task. You can also do that with the branches as well that you pointed out,
Yep.
right? So all these things that are like that will help a lot. So yeah, with that, we'd like to thank you and hope to see you soon in our next event.
Absolutely. Thanks a lot, guys. I'm going to go offline now.
Yeah, for sure. And bye bye, Muhammad. Have a great day.